Hello everyone. In this video, we are going to discuss the few terminologies which are related to the growth of the crop. Those are duty, delta, and the base period of the crop. So let's start. Now, as we are aware that every crop requires certain amount of water for its complete growth. So this water requirement of the crop, it signifies the total quantity of the water which is required for the growth of the crop and the way in which it is required. That is signified by the water requirement of the particular crop. Now, if we look at the typical growth stages of the particular crop, so the first stage that should come to our mind is the preparation of the land before sowing the crop. That means there will be certain amount of water which will be sprayed onto the ground so that the sufficient moisture is retained by the soil before the seed is sown into the soil. So at particular instant of the time we will be sowing this seed. So as you can see here, this particular crop that has been sown in the month of the April, while the sufficient amount of water will be supplied through the methods of the irrigation in between the different stages of the growth of the plant. So that means we will apply the water for the land preparation after sowing, then before seedling, after jointing, then before flowering, then before filling, and at last before maturity. This maturity means that the complete growth of the plant that has taken place. After this maturity of the crop has been achieved, the next stage in this cycle will be the harvesting of the crop. So that means the last stage in the growth of the crop, that will be the harvesting of the crop. And this total amount of water which will be required in between, so here the water will be required, at this time the water will be required. The part I am highlighting, that is signifying the water which is required. Now this total amount of water, that will be the total quantity of water that is required by the crop for its maturity stage. Now based upon these values, we are having different parameters which are used for the definition of the complete growth of the plant. The first term in that is the crop period. What is that crop period? So it is the time period between the sowing of the crop and to the harvesting period. That means this duration of April 18 to the, let's say, this harvesting of the crop that is done in the October month. So this time period, this will be denoting the crop period of that particular crop. So this crop period is defined as the time lapsed from the instant of the sowing. That means the moment you sow the crop period will start and it will be terminated at the instant of the harvesting. That means when you cut the crop from the ground. That means when you harvest the particular crop. This duration is known as the crop period. Now what is this base period? That is to be understood. Now this base period is defined as the time interval from the instant when the first watering was done. So the first time when the water was applied, so this is the stage of the first watering that is used to prepare the land for the irrigation purpose. So this base period, that is defined as the time interval between the first watering that will be done at the pre-sowing stage. This stage of the land preparation, that is also known as the pre-sowing stage. So the time interval from the pre-sowing stage to the last watering. So the last watering that will be done, that will be before maturity or before the harvesting of the crop. This will be the instant of the last watering. So this time interval, that is known as the base period of the crop. So the base period is the time between the first watering of the crop to the last watering of the crop. Now for the usual purposes, this crop period that comes out to be greater than base period. But for practical purposes, this crop period that is taken as equal to the base period, and we will be using them interchangeably. Then the next term that comes to our mind, that is the delta of the crops. But what is this delta of the crop? So as we have discussed, that every crop that requires a certain amount of the water, and that amount of water is required after a fixed interval of time. As you can see in the previous image, that the water was required before this sowing stage, that was known as the pre-sowing stage. Then the water was required before this seedling stage, that means after this interval of time. Then again after a certain interval of time the water was again required. So that means after certain fixed interval of time for a particular crop, the water will be required, and this will be done throughout the growth period of the crop. Now this depth of the water which is required every time, it varies from 5 to 10 centimeter of the depth. That means if this is the ground level, on top of this the amount of water which is to be stagnated for the growth of the crop, that varies from 5 to 10 centimeter, depending upon the type of soil, the type of crop, and the type of the climate. And the time interval at which it is required, that varies from 6 to 15 days. So that means, let's say this is the time scale of the growth of the crop. So at this point the 5 centimeter of the water was required, again 5 centimeter of the water was required, again 5 centimeter of the water required. After certain time it was 10 centimeter, and again it was 5 centimeter. So that means this will be the amount of water which will be required at certain fixed interval. Now if we total this amount of water which is required, that means 5 plus 5 plus 5, then plus 10 and 5, this will yield into the total quantity of water which is required throughout the growth period of the crop. That means if we are to signify the total amount of water in certain parameters, that means if we take this land, let's say this is a piece of the land which is having certain area. Now on top of it the water will be resting. Now let's say this area is A, and this depth of the water which is required, that is D. So the total quantity of water which will be stored in this area, that will be the volume of water. So the volume of water that will be stored, that is equal to the multiplication of the area with the depth of the water. Now if we consider that this area is 1 unit, that means this amount of water which is stored over here, or the amount of water which is required, that can also be represented in terms of the depth. So this total quantity of the water which was required for the growth of the crop, that may be expressed in terms of the depth or in terms of the volume. Both can be done. Now this water was required to raise the crop over a unit area. If you are defining it in terms of depth, that means the area will be unit, and this amount of water, that is known as the delta of the crop. So if you look at the different crops in Indian context, so for example the first one is the sugarcane. So the sugarcane, it requires 120 centimeter depth of the water for its complete growth. Similarly this rice, that also requires 120 centimeter depth of the water. Now the next important crop, that is the wheat. So it requires 40 centimeter of the water. Now these are the certain values which you should remember, and if you can remember all of them, then that is good enough, but you must remember these three at least. So if we look at the problem, it is saying that if the rice crop, it requires 10 centimeter depth of the water, if the rice crop, it requires 10 centimeter depth of the water at an average interval of about 10 days. and the crop period for the rice is 120 days. Find out the delta for the rice. So what data question is giving us that if this is the time scale of the crop, so the rice crop, it requires 10 centimeter of the water, then after 10 days it will be consumed and again it will require 10 centimeter of the water. Now this crop period, that can also be said as the base period, because I've already told you that this will be interchangeably used. So that means the total time in which the crop will be fully matured, this time period is of 120 days, and after every 10 days the 10 centimeter of the water will be required. After every 10 days 10 centimeter of the water will be required. Therefore the number of waterings, that means the number of times irrigation will be carried out. This watering means that the number of times the irrigation will be carried out. So number of waterings will be calculated as the crop period, that is 120 days, divided by the number of days after which the irrigation is to be required. So that means after every 10 days the irrigation has to be carried out. So the total number of waterings, they will be equal to 12. And in each watering, that means in each time the 10 centimeter of the water has to be supplied. Therefore total amount of water which is required for the growth of the crop, that is the number of waterings into the water required in each watering, that is 10 centimeter. So therefore the total amount of water which is required, that is equal to 120 centimeter. And according to the definition of the delta for a particular crop, this total amount of water which is required, that is none other than the delta for that particular crop. So the delta for rice is equal to 120 centimeter. That is the answer. Then moving on to the next topic, that is the duty of a crop. That is the duty of a crop. Now what is this duty? What do we mean by this term? So this duty, it refers to the area of the land that can be irrigated with the unit volume of the irrigation water. That means, let's say this is the area of the land, certain area of the land, and let's say this is the area of the land, and from this side we are having this source of the water. That means this water is applied from this side. Now let's say if the volume of the water which is supplied, that is equal to 1 cubic meter, and under the influence of this volume of the water, certain area of the land that will be irrigated, not the complete area. So this area which will be irrigated, this area that will be known as the duty of this particular crop. That means if in the entire field this crop was grown and this volume of water that was able to irrigate only this much area, not the entire field, then the duty of the crop will be equal to this area only. Now how do we define this? So quantitatively, duty is defined as the area of the land that is expressed in the hectares that can be irrigated with the unit discharge. That means the amount of water which is supplied to the field, that is equal to 1 cubic meter per second, or that is also written as 1 cubic, that is flowing throughout the base period. That means when the crop is to be fully matured, throughout its growth period the water will be supplied, and that value will be equal to 1 cubic meter per second, and the base period that is expressed in number of days. Now let's assume that there is one field that is having certain area. Now let's say there is one field which is having certain area over which only one type of crop was grown. Let's say the crop grown, that was the rice. Let's say there is only one crop which is grown over the entire field. Now when we supply the water, this particular crop, that will require certain depth of the water. So because of that depth, that is required, if let's say we have supplied 5 cubic meter volume of the water, let's say we have supplied the 5 cubic meter volume of the water, and the area of this land, that is the equal to 2 square meter, because these are just random units or the random numbers. So that means the depth of water which can be fulfilled here, which can be achieved in this field, that will be the volume divided by the area. That means 2.5 meter of the depth of the water can be provided here, given that the volume that was supplied, that was is equal to 5 cubic meter, and the area of the land, that was 2 square meter. So this area for 1 unit, so for 5 cubic meter, this area was 2 square meter. So for 1 cubic meter of the water, the area will be 2 by 5 square meter, that will be 0.4 square meter. So this will be the duty of this particular crop. So there are different values which are suggested in the Indian context. So for the sugar cane, this value of the duty, that is 730 hectares. That means if we supply the 1 cubic meter per second of the water, then the area of the field which can be irrigated under this, that is equal to 730 hectares. And mind you that 1 hectare, that is equals to 10 raised to the power 4 square meter. This is an important conversion which you should remember. So this much area will be irrigated if the 1 cubic meter per second of the water is supplied to the field in which the crop of the sugar cane is present. Then for the rice, the duty will be 775 hectares per cubic, and then the crop of the rabi, that means the crop that is wheat, it will be having 1800 hectares per cubic. So the usual or the general crops that are usually asked, they are sugarcane, rice, and the wheat. So this data you must remember. Now this duty is different at the different places. So how does that vary? So if you look at this figure here, that is representing the canal irrigation system. This is the natural stream which is flowing here. Okay, this is the natural stream which is flowing here, and the water is taken from this natural stream with the help of the canals. So the first canal which is off taking from this natural stream, that is known as the main canal. Then this main canal will be further divided into the different one. So let's say this main canal was, another canal was taken from this main canal, which is known as the branch canal. Then this branch canal will be distributed again, and that is known as the major distributary. Then again, if certain other stream is taken out from that, that is known as the minor distributary. And ultimately the water will be supplied to the field. If it is supplied directly to the field, for example, as you can see, this was the main canal, and from the main canal only you are taking the direct supply to the field. So this last part of the canal system, which is taking the water directly to the field, that is known as the water course, or that is also known as the field channel. Now that was the kind of a real image just to show you that how this canal irrigation system works. Now we will look at the layout system of this. So this water is flowing in this river. This is the natural stream. Certain barrage will be constructed across this river. That means there will be certain obstruction which will be created here. Let's say this is in this form. This is the barrage which is constructed. So it will cause the water to accumulate behind this barrage or the weir. Now when the water is accumulated at this place, this water will be diverted into the canal. So the first canal which takes the water, that is known as the main canal. This water will be coming here. Now when this water is taken from this main canal into the another canal, that first division that is known as the branch canal. This water will be going through this. Then if again from the continuous branch canal another stream is taken out, that is known as the distributary. Now this distributary may be the major one or the minor one. Now out of these distributaries, if directly the water is taken to the field, so the last network of this canal system, that is known as the water course or the field channel, which is taking water directly to the field. Now here an important installation is done, which is known as the outlet, which is provided at the head of the water course. Now this outlet is very important because the construction of these facilities, that is the main canal, the branch canal, the distributary, all of this till this point, that comes under the department of the irrigation. That means till this point the responsibility and the accountability for the maintenance of these components and the construction of these components, that lies with the irrigation department or with the respective governments. After this point, after this outlet point, now this point, it defines the barrier between the state and the farmer. So after this, the farmer will be free to take the water from this minor distributary or from this water course with the help of the certain channels which will be constructed or which will be installed by the farmer himself. Till the outlet point, all the construction was done by the state government, that was the respective state governments. So if we look at the irrigation system, now water flows in this way that I've shown to you. Now when the water is flowing, it is exposed to the atmosphere. This water is exposed to the atmosphere, and let's say this is the sun which is present, because of which there will be a certain amount of heat which will be generated. So certain amount of the water that will be evaporating, that will be getting evaporated because of the process known as the evaporation. Certain amount of the water that will be getting into the ground, which is known as the percolation. Certain amount of the water that will be going into the ground through the process which is known as the percolation. That means when the water is traveling in these constructed canals, there is some amount of water which is lost because of this evaporation and the percolation. So this amount of water which is lost, that is known as the conveyance loss, or that is also known as the transportation loss, because this water was lost when the water was in the stages of the transportation or in the stages of the conveying the water to the farmer. So that means if we supply 10 units of the water here, when it enters into the main canal, let's say 0.5 unit has been evaporated or percolated, that means the 9.5 only that will be flowing into the main canal. Then again 0.5 is lost because of the exposure to the atmosphere. Then the branch canal will be taking 9, then distributary will be taking 8.5, and this minor will be taking 8, and ultimately onto the ground this 7.5 unit will be supplied. So that means this was the loss which was occurring throughout this network. So ultimately the amount of unit that was supplied, that was is equal to 10, but the total units which reached the ground, they were equal to 7.5. Now these 2.5 difference that accounts for the conveyance or the transportation loss. So as we move ahead in this irrigation system, in the canal system, from head to the main canal to the water course, the length is increasing. That means if we are measuring the water only at this point, and if we are measuring the water directly at this point, then the difference between the canal head regulator, the water which is present at the canal head regulator and the field, that is the highest, and that difference is of 2.5. While if we look at the difference between the water level at the head of the main canal or at the head of the branch canal and the field, that is 2, that is difference between 9.5 and 7.5. As we are moving closer to the field, the difference or the conveyance loss, that is decreasing. The conveyance loss, that is decreasing. So that means the availability of the water, if we are measuring at this point, at this, let's say if you are measuring the availability of the water at this outlet point, so it will be the highest at this point, because the amount of water which was present here, let's say this amount of water which was present, that was 7.5 only. So this total amount of water that has been supplied to the field, and there is almost zero loss of the water. So if we supply the 7.5 units of the water, the 7.5 will be actually reaching the ground. So the duty was defined as the area which will be irrigated because of the 1 unit of the water. That was the definition of the duty. Now in this network, as you can see, if we supply 7.5 unit of the water at the head of the field, this will be entirely used as the 7.5 value only. But if you supply the 10 units of the water, the amount of water which will be reaching, that will be 7.5. That means the duty at this canal head regulator or at the head of the main canal, that will be the least, and it will be highest at the entrance of the field. So the duty, it varies from place to place because there will be different amount of water which will be available. So duty varies from place to place, and it increases as we move from head of the main canal to the field. So in this direction the duty will be increasing, and the duty which is available at the outlet, that is having certain other name. So the duty available at outlet, that is known as the outlet discharge factor. The duty which is available at the outlet, or when the role of the state government that diminishes, so the amount of water that will be available at the outlet because of the installation done by the government, that is known as the outlet discharge factor, and that's why this term is important. Now as you can see here, this canal which is constructed, now this canal, this will be the responsibility of the government, that will be the respective state government which will be constructing this, but the supply of the water from here, that will be done by the farmer. The farmers will be responsible for this taking off of the water from these canal systems. Now there is two types of duty, that is the flow duty or the storage duty. The normal duty that we are discussing, that is the flow duty, that means the water which is available because of the flowing water, the irrigation that can be carried out because of the flowing water. While this storage duty, that comes out when the water is stored, as the name itself suggests, when the water is stored, that means how much area can be irrigated with the help of the water which is stored behind a reservoir or into a reservoir. For example, if you look at a dam constructed, so let's say this is a typical dam. Now this will be stopping, or this will be accumulating the amount of water behind it. Now this is known as the reservoir. Now this reservoir will be having certain volume, So how much area can be irrigated with the help of this water which is stored in the reservoir? That is known as the storage duty. So this completes the discussion regarding the basic terminologies. In the next video, we will analyze the relationship between these three terms that we have discussed, that is the duty, delta and the base period. Thank you.